Okay, so now we're going to have a look at the distribution of histograms and what is meant by the term skew. So if I start with the diagram in the middle here, so I've just drawn some simple histograms to show you the difference. So this one is what we call a symmetrical distribution. So if I was commenting on distribution, I would talk about it being symmetrical. This means there's no skew whatsoever. And you can tell that because if I were to draw our frequency polygon on, see how it makes a beautiful little hill? And what it means is there's the same amount of data on either side. The bulk of the data sits in the middle, and then it's about the same on either side. What you'll find is the mean will be about there. You'll probably find the mean in that center column right there if it's a very symmetrical distribution. This side, however, what you will find is, if we draw in our polygon again, so you can see that the bulk of the data actually sits further along to the right. So we call this, running out, a negative skew. Okay, and that's because the long tail, and we want to remember that, the long tail is to the negative end of a number line. Okay, so it's on the negative side of the peak of the data. So what you'll find here is, instead of the mean being right in the center, you'll find that the mean actually occurs slightly further along in the data set. So if these are all your data points down the bottom, it'll occur further along and closer to the bulk of the data, the peak of the data there. Similarly, on this side, you can see this is a positive skew. And for the same reason, the long tail goes towards the positive end. Okay, and we can see that when we draw, almost looks like a roller coaster, these really. Let's just put that in a little better. Okay, and again, what you'll find is the mean, if all your data sets are along the bottom here, the mean will actually occur a little earlier on because the bulk of the data occurs earlier on in the data set. Early on, positive, later on, negative. Right in the center, symmetrical, okay? It's what we used to refer to as a bell curve, yeah? Kind of looks like a bell. So it's really important that you're able to comment on the distribution of the data, and that will really depend on, that's part of the reason why we represent it graphically. It's really easy to tell, really easy to see. And this way, not only can we see where the skew lies, we can see when the bulk of our data sits somewhere other than the center, but it also gives us an indication of where our measures of center will be.